class invited.
Assalamualaikum and good afternoon everyone. Today my group and I would like to present our Bioscience web project related to our program. This website was developed using HTML and published through GitHub page. First of all, let me introduce myself. My name is HASANAH binti Tuan PADILAH and I'm a student from University Malaysia Kelantan in the Agro Product Technology program. Today, I will explain my Bioscience problem entitled Enzymatic Extraction Optimization of Malaysian Roselle, the mathematical model used and how calculus is applied in the food processing technology. The bioscience problem that I select is about the enzymatic extraction process of Malaysian roselle, also known as Hibiscus septerifer. In the food industry, pectinase enzymes are used to break down plant cell walls in order to extract antioxidants and polyphenols from roselle. However, the main challenge is determining the best extraction time. If the extraction time is too short, the bioactive compounds are not fully extracted. But if the extraction process is too long, the extraction rate slows down and may reduce product quality due to heat degradation. Therefore, this project uses calculus and mathematical modeling to determine the optimal extraction time and maximum yield. Importance of studying this bioscience problem. The study is important because it helps introduce improved extraction efficiency while reducing energy and processing costs. By identifying the best extraction time, industries can save time, reduce waste, maintain nutrient quality, and improve production efficiency. Besides that, this project also shows how mathematics and calculus can be applied in real bioscience and agro-product technology situation. Now, I will explain each section on my website. First section, Bioscience problem. In this section, I explain the real industrial issue related to roselle extraction. The website explains that pectinase enzymes are used to extract antioxidant-rich compound from roselle. The important point here is identifying the stage where the extraction process begins to slow down, also known as diminishing returns. Second section, mathematical modeling. Next, the section shows the mathematical model used in this project. The yield function is f of t equals negative 2.2t cubed plus 50.5 t square plus 12t. This equation represents the relationship between extraction time and total polyphenol yield, where ft is the extraction yield and t is time in hours. Then, differentiation was applied to obtain the derivative. F of t equals negative 6.6t square plus 31t plus 12. This derivative function measures the rate of change of extraction yield over time. Third section, kinetic yield curve graph. Next is the graph section. This graph shows how the extraction yield changes over time. At the beginning, the yield increases rapidly as extraction becomes more effective. Then, around 5 hours, the graph reaches its maximum point, which indicates the optimal extraction times. After that, the graph starts to decrease slightly, showing that the extraction process becomes less efficient. This graph helps users understand the relationship between calculus and bioscience visually and interactively. One recommendation to improve this HTML website is by adding more interactive features such as hover animation, live derivative calculation, or responsive mobile optimization. In conclusion, this project successfully demonstrates how calculus and mathematical modeling can be applied in agro-product technology and food processing. By using derivative and graphical analysis, we can determine the optimal extraction time for Malaysian roselle and improve industrial efficiency. Thank you for listening. Next, I will give to my friend.
Hi, Assalamualaikum. My name is AINA UMMAIRAH binti ISMAIL. My matric number is F25A1891. Today, I'm going to presenting to you my mathematical bioscience project. focusing on a critical pillar of Malaysia's agricultural resilience, food security, specifically within rice post-harvest management. The bioscience and food security problem is in Malaysia, rice or padi is harvested at high moisture content levels around 24% to 26%. To prevent rapid fungal growth, grain respiration, and spoilage, which directly threaten national rice self-sufficiency levels, the moisture must be brought down to a safe storage level of 14% within 24 hours using mechanical dryers. I've been using this mathematical modeling calculus to understand the rate of moisture loss over time allows agricultural engineers to optimize drying temperature profile, preventing grains from cracking and preserving grain quality. To analyze this biological process mathematically, we modeled the moisture content reduction over a 12 hours drying cycle using a quadratic function. This fx function. X is drying time and fx is the moisture content percentage. To find the instantaneous rate of drying at any hour, we find the first derivative f of x using the power rule, where f of x represents the moisture loss rate per hour. Now, let's look closely at the data point map in my interactive graph. This model reflects realistic baseline parameter adapted from Malaysian Agricultural Research and Development Institute, MOHD and BERNA's Safe Storage Guidelines.
Sir, we've had multiple complaints. I'm going to have to
If we take a look at the hour zero, the current moisture content is at 24%, and the calculated rate of change f of x is at the negative 1.4% per hour. In the food security viewpoint, at this initial stage, surface water is evaporating rapidly. The high negative rate shows the dryer is working efficiently. This quick drop is crucial to stunt mold development early. And then we move to the hour 5. The moisture content at hour 5 is 18.25%, and the calculated rate of change is negative 0.9% per hour. The drying rate is slowing down because water now has to move from the core for the deep inside the rice core to the outer surface. Consistent temperature must be maintained to prevent grain cracking. And lastly, we take a look at the hour 10. At hour 10, the current moisture content is at 15%, and the calculated rate of change is negative 0.4% per hour. This moisture level is approaching the safe target of 14%. Notice that the rate of change is very close to zero. Further drying will only waste industrial energy and cause weight loss, reduce market value for farmers. In the conclusion, this interactive model demonstrates that calculus is not just theoretical, it is a vital tool in bioscience and food security. By calculating the exact derivative f of x, food scientists and agricultural engineers can predict precisely how fast moisture is leaving the grain at any given hour or any given minute. This ensures that the mechanical dryers operate efficiently, avoiding overdrying, which wastes energy and cracks the rice, or underdrying, which leads to fungal spoilage. Ultimately, optimizing this curve means securing our national rice supply and ensuring stable post-harvest management. That's all from me. Thank you.
Good evening, everyone. My name is SYAFIQ and my metric number is F25A2059. Today, I will present my project, Grow Calculus. This project used math to study how MD2 pineapple grow over 40 weeks. We use a cube function ft, which mean the plant height function, to calculate the height f of t is equal to negative 0.001 t cube plus 0.05 plus s square plus 0.5 t plus 10. To find the growth speed, we use the first derivative function f of t, which means the growth velocity function f to t is equal to negative 0.003 plus s square plus 0.1 plus 0.5. This function shows the slope of our height graph. This math analysis is important to find the maximum growth rate of the plant using the second derivative when f of t equals 0. This data also help farmer plan the best fertilizer schedule based on MOHD and LPNM standard. Now let's look at the graph. At week 0, the starting area is 10 cm, which is the intercept. The starting growth speed is 0.5 per week. In the middle phase, the green line reached its higher point, which is 15 to 20 week. This means the plant is growing very fast. Finally, near week 40, which is 35 to 14 week, the green line goes down to 0 and the blue line become flat. This shows the plant stop growing tall and it's ready to produce fruits. In conclusion, my suggestion to improve this page is add a dynamic intelligent line using JavaScript. This feature will show a starlight line on the graph to explain the slope more clearly. That's all for me.
Good morning, everyone. My name is Muhammad AIMAN bin Muhammad JOHARI. My metric number is F25B1669. And today I will present you guys about my website project about a bioscience problem related to food security. This website discusses problems such as food waste, crop disease, and challenges in food production. This problem can reduce food supply and affect people around the world. Climate change and poor storage system also make the situation worse. This bioscience problem is important to study because food is a basic human need. If food production decreases or too much food is wasted, people may face hunger and food shortage. By studying this issue, scientists can find better ways to improve farming, reduce waste, and increase food production. In this website, the homepage introduces the topic of food security. The problem statement section explains issues like crop disease and food spoilage. The technology section shows how AI smart technology can help farmers monitor crops and improve food storage. The important section explains why food security is important for health, economy, and human survival. Lastly, the conclusion summarizes the overall discussion and reminds us the technology and bioscience are important for future sustainability. One recommendation to improve this HTML website is by adding more interactivity such as animation, videos, and graphs, so user can understand by information more easily and enjoy the presentation better. In conclusion, these websites help us understand the importance of food security and how bioscience and technology can help solve global food problems. Thank you.
I got a condo in Manhattan. Baby girl, what's happening? You and your